Adding vectors of different angles can be done using these 6 steps. Click on any one of them right now if you wish to jump ahead. First, we're going to resolve the vectors into their x and y components. Then we'll add all the x components to get the total x resultant. Then we'll add all the y components to get the total y resultant. We'll draw a triangle diagram and determine the magnitude of the resultant using the Pythagorean theorem. Then we'll find the angle using the inverse tan function. And finally, we'll write the magnitude and direction of the vector sum. So here we have our 2 vectors to be added together. We're going to start by resolving these vectors into their x and y components. So for this first vector, we can see that it's going east 15 degrees north, and so I'm going to draw an arrow to represent that. This arrow does not need to be perfect, and it does not need to be straight. It's just to help us to get through this. So here we have our vector. Because it's going east and then north, I'm going to draw the x and y components in that order. And again, this is just a diagram to help us. Now this is a centimeters, which means this is a displacement. So this right here is dx, and this is our dy. This is our 5.3 centimeter vector here. Because we went in the order given, east and the north, we know that our theta is right here. So because our theta is here, that means this is our opposite side, this is our adjacent side, this is our hypotenuse. So we'll start by listing our knowns. Our hypotenuse is 5.3 centimeters. Theta, our angle, is 15 degrees. The opposite side is our dy, and the adjacent side is our dx. Now we're going to use the equation hypotenuse times the sine of theta is our opposite side. And then we substitute. Our opposite is going to be our dx. So now we plugged it into the calculator and we make sure that our calculator is set to degrees and not radians or anything else. And when we do that, we find our dy is equal to 1.37 centimeters. And the direction, if we look at our diagram, is to the north. For the adjacent side, we're going to use cosine. And so 5.3 centimeters times cosine of 15 degrees will be our dx. And solving that, we get 5.12 centimeters, and this one's going to the east. And so we've resolved our first vector. Our second vector, 7.7 centimeters, is going south and 70 degrees to the east. Now it's mostly going east because of the 70 degrees, so I'm going to draw it in that direction. Again, it does not need to be perfect. This is just a diagram to help us. I'm going to draw the legs of the triangle south and then east. These are vectors. And so this is our vector, 7.7 centimeters. Again, this is our dy because it is vertical. This is our dx because it is horizontal. And because we went south and then east, we know our theta is at our starting location. And that means that the dy is going to be adjacent and the dx will be our opposite. And there's our hypotenuse. So our hypotenuse is 7.7 centimeters. Our theta is 70 degrees. Our opposite This time it's our dx, which is different than it was up here, and our adjacent is our dy. So we're going to use the same equations as before. And our h is 7.7 centimeters. Sine of 70 degrees will be our opposite, which is our dx this time. And so when we put that into the calculator, our dx will be 7.24 centimeters. And again, it is going east. We'll separate that out. For our opposite, I'm sorry, that was our opposite. For our adjacent, we'll have to use cosine. 7.7 centimeters. Cosine of 70 degrees is our dy, our adjacent side this time. So put that into the calculator and we end up getting for our dy 2.63 centimeters, and our dy at this time is pointing to the south. Okay, so all of that is our step 1. And you could put a line there if you like, and we'll go on to step 2. Step 2 is simply adding up our dx's to get our resultant dx. So we're going to take our 5.12 centimeters to the east and add that to our 7.24 centimeters to the east, meaning that our total dx will be, and because they're both going to the east, we could just add them, 12.36 centimeters to the east. And that is our step 2. Our step 3 would be to add our dy, so I need to scooch that up a little bit here so we can see that. Our total dy will be 1.37 centimeters to the north plus 2.63 centimeters to the south. Now they're going in opposite directions, so we'll have to subtract, which means that we will get 1.26 centimeters, and because it was more south than north, we end up to the south of where we began. So that is our step 3. Step 4 will involve drawing a triangle and finding the resultant. So we know we're going to go east and then south. It doesn't matter what direction we go, but I'm just going to stick in the order that we have. So I'm going to draw a triangle. Again, it does not need to be perfect. This is just a diagram to help us visualize all this. That's going to be our 12.36 centimeters to the east, and I wrote that on top because I know I'm going to be going south for down. And again, it does not need to be to scale for this purpose. A resultant, and it is helpful to take a straight edge and draw these lines, because even though it's not to scale, it's nice to be neat about this. Now, this is a preview of our final answer here. This is the vector we're trying to find. So we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. And a, it doesn't matter which is which, so it'll be 1.26 centimeters squared plus 12.36 centimeters squared equals our hypotenuse squared. And so when you solve that, our hypotenuse ends up being 12.42 centimeters. Next step. Our step 5 involves finding this angle right here. And why this angle? Because we went east and then we went south. So we're going to find that angle. For that, we're just going to use the inverse tan function, the inverse tangent, and that is O over A, opposite over adjacent. So our angle will be the inverse tangent of 1.26 over 12.36, because that is our opposite and that is our adjacent. And so our angle, when we plug that into our calculator, is 5.8 degrees. That is step 5. And our final step is to combine these and get our final answer. So the hypotenuse over here is the magnitude of our vector, so we're going to write 12.4 centimeters. And our direction, well, we went east and then south. So it is east and 5.8 degrees south. Box around it, and we're done.